Hello, this is the Genie academic program, and this is the program we will use to draw a probabilistic network to calculate the probabilities of your hypothesis given the evidence you have collected automatically. So here I have the program, and then I've here on the side a little text editor to keep note of what I'm doing. But this is the program here on the left side. So the first step is to state what our hypotheses are. And in order to do that, you just click on this yellow dot up here, and then you drop it somewhere in the middle of the screen, and this gives you node 1. I think it's good to relabel it saying hypothesis, because this node can make it a little bigger. This node describes what your hypotheses are. And I think it's a good thing to have this node viewed as a bar chart. And if you double click on it, so you here have the top of the box, you double click on hypothesis, and you get this menu, and then you go to definition. Here you have state 0 and state 1. I think a good thing here is to relabel those, giving them names that are the names of your hypothesis. So I'm going to rename them with H1 and H2, for example. I know that some of you will have 2 hypotheses, so this would be enough. Some of you would be more than 2 hypotheses. So if you have, for example, 3 hypotheses, you should add an extra line here in this table. So you will get an extra line by clicking here, and then it's good to relabel it H3. So these are your 3 hypotheses. So you click OK, and so now you have this little box. That is the box that represents your hypothesis, and they're listed here H1, H2, and H3. If you double click on hypothesis again, you get the same menu as before. You go to definition. Here you have these values on the right side of this table, and these values represent probabilities, and in particular they are your prior probabilities. They are the prior probabilities of each hypothesis. So let's suppose that your research shows that the prior probability of H1 is relatively low, let's say 0.1, so you can write it here. The prior probability of H2 is 0.6, let's say. And you see that here we get an error message because these 3 probabilities have to add up to 100% or to 1. And so the probability of H3 has to be 0.3. So now they all add up to 100%. So these are your prior probabilities. So we can click OK. And if you want to see them displayed in this little graph, you can click on this lighting sign, and then you see that this just displays the 3 probabilities, the 3 prior probabilities for each one of your hypotheses. Now the next step now is to combine this with the evidence you have acquired. So in order to do that, we need to expand our probabilistic graph with your evidence. So go again on this towards this yellow dot, and you drop it somewhere here. So this will give you node 2. It's good to rename it, let's say, evidence E1. You can make it bigger as well. So this is the node that represents your evidence E1. So the first piece of evidence you collected. You can do the same with another piece of evidence, let's say E2. Can rename this E2. And this will depend. Some of you will have 2 pieces of evidence. Some of you will have more. So let's suppose that, we have here like another piece of evidence, call it E3, and let's say another one, E4 that you have, and there could be more. So let's say E5 and so on. This really depends on how many pieces of evidence you have collected. So you can arrange them however you want. Now, the next step here is to connect the hypothesis to your various pieces of evidence. And to do that in this probabilistic graphs, to do that, you just click on this arrow and you just drag it from the hypothesis box to evidence 1. Then you click on the arrow again, you drag it from the hypothesis box to evidence 2. You click again on the arrow, you drag it from the hypothesis box to evidence 3. Click on the arrow again, you drag it from the hypothesis box to evidence 4, and finally clicking on the arrow again, you drag it from the hypothesis box to evidence 5. So now we have connected our hypothesis to the various pieces of evidence. And so let's start with E1. So double click on it, we go on to definition. Here we have state 0 and state 1. I think for clarity it's always good to rename this present and absent. What does this mean? Well, this means that the evidence is present, so that we kind of found that evidence, and absent means that we did not find the evidence. So we are considering evidence E1, and here you can see in this table these different values. Now you have default values, 0.5, 0.5 for everything. But what you want to insert in this table are the probabilities of the evidence given the hypothesis. And so just to be clear, what you need to put in this table, in the top line of table, are the probability of the evidence 1 given hypothesis 1, and then probability of evidence 1 given hypothesis 2, and then also the probability of evidence 1 given hypothesis 3. Okay, so what are these values? Well, this will depend on your research and what you have established, but suppose that you found out that the probability of the evidence E1 being present given hypothesis H1 is 0.1. So you can put it here. So this, just to be clear, so means that you found out that the probabilities of evidence E1 given hypothesis H1 is 10%, or 0.1. Now what's important here is that the bottom here, so the value at the bottom, has to add up to 100%. So this is the complement. So here you'll have to put 0.9. So absent is basically the complement. So what we have here is that the probability of evidence E1 complement given H1 is 90%. Oh, sorry. 90%. Okay, so that's the first column. Now let's look at the second one. So here the probability, suppose you've done some research and found out that this is probability 0.2, and so the one at the bottom has to be 0.8. And so just to be clear, what you are describing here is the probability of E1 given H2. This is 80%. Oh, I'm sorry. Here I should put 0.8, and this one I should put 0.2. Okay, so this one is probability 80%. And so it means that the probability of E1 complement given H2 has to be 20%. Okay, so this is the the second column in our table. And we can do the same for the third. So suppose you've done some research and discover that the probability of E1 given H3 is 0.55. So probability of E1 given H3 is 55%. And therefore the probability of the complement of E1 has to be 0.45. So this is the probability of E1 E1 complement given H3 has to be 45%. Okay, so the first column here describes 10% or 0.1 is the probability of E1 given H1, and what's at the bottom is the probability of the complement of E1, or the fact that the evidence is absent, is not present, given H1, that has to be 90%. So these two values here have to add up to 100%. And then you do the same for the other column. So this is the probability of E1 given H2, and this is 80%. And then we have the probability of the complement of E1 given H2, this is 20%. And then for the third column, we have the probability of E1 given H3, this is 55%. And finally, the probability of the complement of E1, or the fact that the evidence is absent, given H2 is 45%. Okay, so here is what we have. These values don't appear, the value that we've written don't appear in our graph, but if we double click on this, we can see them in this table. So even if they don't appear, they are being recorded. I think a good thing here is to visualize this as a node. So you go under node and as a bar chart, you go under node view as and bar chart. So you get these two things. Now you can do the same with all the other pieces of evidence. So I'm going to do one with H2 just to show you. So same thing here. So let me clear this up. Let me clear these values. So we have, I'm going to rename this for clarity present and absent. So this just means that the evidence is present, the evidence is absent. And suppose you've done research and you've shown that the probability of, in this case, we have to talk about E2, not E1 anymore. So I have to rename this. So suppose we have found that the probability of E2 given hypothesis H1 is, let's say, 0.75. And so 0.75. So it's 75%. 75%. So this means that the probability of the evidence being absent given H1 is 25%, and so I'm writing it down here as well. Suppose now that our research shows that the probability of E2 given H2 is say 8%, and so it means that the probability of the complement of E2 has to be 92%. And so we can put these values here, so 0.08 and then 0.92. And then finally, suppose that our research shows that the probability of 0.2 of E2 given H3 is 99%, and therefore the probability of E2, the complement of E2, given H3 has to be 1%. So we can put these values here in the third column. So this is going to be 0.99 and this is going to be 0.01. Okay, so we have our values again assigned according to our research, and so we can click OK, and this we can visualize this as a bar chart. That's easier. We have present and absent, even though the values that we've inserted are not represented here, they are being recorded in the back. So we can do the same procedure for all the others. I'm not going to explain again step by step. I'll do them very quickly. So I'll rename this present and absent and insert some random values, let's say 0.9 and 0.1, 0.4 and 0.6, 0. Let's say 82, well I did 82, 0.83 and 0.07, so 0.17. And okay, so this gives us for E4. Again, it's a good thing to represent this as a bar chart. Let's do the same with E3. So present and absent. I'm gonna insert some value, 0.7, so that has to be 0.3, 0.1, 0.9, 0.9, and then 0.3, and then 0.7. Okay, so this is for E3, present and absent. Oops, this is not spelled properly. We can visualize this as a bar chart. It's always better for clarity. And then finally, E5, present and absent. Let's say 0.35 right here. So this is 0.65, then 0.05, and then 0.95, and then let's see here 0.25, and so 0.75. Okay, so this I didn't write it properly, so 0.25. Okay, so they all add to 100, the different columns, and so we have everything here. You can visualize E5 as a bar chart as well. So here we see that we have our priors for the hypothesis 10%, 60%, and 30%. We have assigned probabilities to the various pieces of evidence relative to the hypothesis. And so now it's the time to tell the program that these pieces of evidence are what we have. We actually have these 5 pieces of evidence. So we double click on present to tell the program that these pieces of evidence are in fact present, meaning that we collected them, we have them. Now you see that interestingly the probabilities of the hypothesis have disappeared, because what the program now is supposed to do is to update the probabilities of the hypothesis based on the acquisition of these 5 pieces of evidence. And to see this, to see the result of this computation, you can just click on this lightning sign, the update sign, and this is gonna give you the probabilities of the 3 hypotheses given the 5 pieces of evidence that we have collected. And you see that these probabilities are different from the prior probabilities.